everyone. Welcome to the session. Today we'll be starting a new topic on number properties. This is a very important topic in every exam, not just in UPSC, in every exam. This is a very important topic. Good evening, Sweta. Good evening, Suhas. So I'll wait for another 30 seconds for people to join. I hope you have solved the previous overlapping sets. Sudhakar, we normally what we do is after the session we keep the videos for some time. Yesterday I think it was there public till 11:30 or 12 o'clock. So we want people who have missed the sessions to, good evening Akash. We want people who have missed the session maybe due to network problem and all to attend live, to get the benefit of the session. So we keep the sessions. We will upload, don't worry Sudhakar, we will upload it, but give us some time, maybe a week's time. We need to edit those videos. We are editing the previous videos also. Once we edit the videos, we'll post it there. Don't worry. So we'll start with today's topic, number properties. So what is numbers? So there are numbers can be classified into real numbers and complex numbers. The chart that I've already prepared. So numbers are real numbers. There are two types of, in a number it can be classified as real numbers and complex numbers. What is a real number? A real number is any number that can be denoted on a number line. These are the real numbers. And complex numbers are the numbers which cannot be represented on a number line. For example, complex number can be 2 plus 3i, where i is a root of -1. And real numbers can further be differentiated or segregated into rational and irrational numbers. Rational numbers are those numbers which are integers and fractions, and even in fractions, these fractions are even if they are recurring, these fractions are, some fractions are terminating and some are recurring, but when they are recurring they have a pattern, whereas in irrational numbers they don't have any particular pattern, they just don't end. And in rational numbers there are two types, integers and fractions. Integers are like -5 plus -4 plus 4 plus 3. These are all integers. And you have even integers are negative and positives. 0 is also an integer. Fractions are nothing but any numbers that can be represented in p/q format. That is, for example, 2/3 or 3/4. So in integers also there are two types here. Again, integers are whole numbers. Whole number is the numbers which include 0. Those are integers which include 0, 1, 2, 3. There are no negative numbers. So if you remove from the integers, if you remove negative numbers, you get whole numbers. And from the whole numbers, if you remove 0, you will get natural numbers. I hope this is clear till now. If you have any doubts, please ask. Yeah. I'll explain it once again. So any numbers can be divided into two, real numbers and complex numbers. Real numbers are the numbers which can be represented on a number line, and complex numbers cannot be represented on a number line. And then we have in real numbers we have we can categorize it into two: rational and irrational numbers. Rational numbers, irrational numbers are the numbers which are not terminating, and there is no pattern in irrational numbers. Whereas in rational numbers, they are terminating, they are integers. I mean, there are two types of rational numbers: integers and fractions. So in integers, we have minus infinity to plus infinity. In fractions can be represented by p by q, and where p is an integer and q is also an integer, p by q. And whole numbers are those integers which starts from 0 and 1, 2, 3, 4 till plus infinity. Whole numbers doesn't have minus, negative or minus infinity here. And then we have natural numbers. Natural numbers are those numbers where 0 is not there. These are the natural numbers where we can count 1, 2, 3, 4 and so on. So I hope this is understood. If there is any doubt, please ask, or else we'll move to the next section. So you don't have to memorize all these things. They'll not directly ask you. This is just for your understanding. There are other important things in number properties that are much more important. Okay, we'll move to the next section then. So we already discussed integers. I mean, integers come under real numbers. Under real, there is rational, and under rational, there are integers and fractions. Now we'll study integers. So in integers, integers can be further divided into even and odd. Even numbers are those numbers that are divisible by 2. Odd numbers are those numbers which are not divisible by 2. 0 is an even number. Zero is an even number. 0, 2, 4, 6. Positive numbers are also even numbers, and negative numbers are also even numbers. So both positive and negative numbers can be even numbers, but these even numbers are the numbers which are divisible by 2. And then we have odd numbers. Odd numbers are the numbers which are not divisible by 2. Those are minus 5, minus 3, plus 1, plus 3, and all such numbers are odd numbers. So we have the rules for these integers. So before going into integers, properties of integers, we'll see the properties of even and odd numbers. For example, if even numbers are added, it is yes, 0 is an even number. So if just take this reading. So for even numbers, for example, in addition, whenever you are adding two numbers that are even, guys, just give me some time. I'll be back again. There is some lag in the connection. Stay online. I'll just stop the streaming and then come back again. Please hold on for some time. Okay, we'll start with the basics here. So we had discussed about the even numbers and odd numbers, and now we'll see the basic properties of even numbers and odd numbers. For example, in addition, whenever we are adding even number and an even number, we get another even number. So whenever you add two even numbers, you get an even number. But whenever you add an even number plus an odd number, you get an odd number. So even plus even is even plus odd is odd. So for example, you can take an example as 4 plus 8. 4 plus 8 would give you 12. 4 is an even, 8 is an odd, sorry, 8 is even, and 12 is also even. But when you're adding in even, that is 4 plus odd number 5, you would get an odd number, that is 9. So this is true always. Even plus even is even, and even plus odd is odd. Whenever, and next is odd plus odd. Odd plus odd is even. So whenever you are adding two odd numbers, you would get an even number. So for example, you can take 1 plus 1 is equal to 2. So 1 is an odd number, another 1 is also an odd number, resultant is 2. So 5 plus 7, two odd numbers. When you add two odd numbers, you have an even number, 12. So this is for addition. The same is with subtraction also. Even minus even is equal to even. Odd minus even is equal to odd. And odd minus odd is equal to even. So you can take examples for this. For example, if I take 12 minus 8 is equal to 4. Odd minus even, I can take odd as minus 5, even as 8. This is equal to minus 3. So odd number minus even number is odd number. Odd number minus odd number is even. 5 minus odd number minus 9 is equal to minus 4. This is an even number. So I hope you understand this. Addition, even plus even is even plus odd is odd. You don't have to by heart these things. You can just use an example there in the exam and see which numbers are. And the more you solve exam problems, you would get used to this. Odd plus odd is even. And similarly, even minus even is even. Odd minus even is odd. Odd minus odd is even. So I've taken examples here. If you have any doubts, please post it in the chat section. And multiplication, whenever you multiply an even number into an even number, you get even number. Even number into odd numbers is equal to even number. Odd number into odd number is odd number. So whenever you are multiplying any two numbers, even if one number is even, the final result will be even. If the final result has to be odd, then there will be no even numbers. Every number, for example, if there are numbers like A into B into C into D into, let it be 100 numbers, and they are saying that the final result is odd, then you clearly know that any of these numbers will not be an even number. Only odd numbers can, when they multiply, will get odd number. If there is any factor of 2 here, then you will end up with an even number. I hope you understand this. If you have any doubts, please ask. Or else we'll move to the next section. This is only about even and odd. Yes, 0 is an even number. 0, 2, 4, 6. Even negative numbers can be even or odd. Is this clear till now? If you have any doubts, ask. Okay. So we'll go to the division part. Division of even and odd numbers. Even number divided by odd number is always an even number. And odd number divided by an odd number will be an odd number. Even number divided by an even number can be an even or odd. We cannot say anything on this. So in this case, I'm telling you only if there is an integer answer. Only when there is an integer answer, if there is an integer, it would be even. If odd number on divided by odd number is an integer, then that would be an odd number. And even number upon or even number, if they are integers, and if the final answer is integer, that can be even or odd. For example, I'll take an example here. 60 divided by 5. This is an even number, this is an odd number. The answer in this case is an integer, that is 12. Since it's an integer, it has to be even number. This is an even number. And whenever you are dividing odd numbers, you cannot get an, whenever you are dividing odd number by odd number, you cannot get an even number because there is no 2 here on in the numerator. For example, if I take 35 divided by 7, they both are odd. This is 5. This is also odd. And then, and when you are dividing even number by even number, you can get even or odd, anything. There is no particular rule for this. Is this clear? I mean, this is even only if, I mean, this is the case only if, whenever the answer is, only if answer is an integer. This is only if an answer is integer. Is this clear? Shall we move to the next part? Okay. We move to the next part. Prime numbers. Numbers can also be segregated as prime numbers. A prime number is any number that has only 2 factors. Prime numbers is any number that has only 2 factors. Only 2 factors. There should be only 2 factors, not more than 2 or not less than 2. What is factors? Factors is any number that divides the other number completely. For example, there is no remainder. The remainder is 0. So if I take 12, then the factors would be 2, 4, 6. So these are the factors of 12. So what are the factors of 12? Factors of 12 are the numbers that divide the number 12 completely, and the remainder would be 0. So 12 divided by 2 is 6, 12 divided by 4 is 3, 12 divided by 6 is 2, and there is one more factor, 3. These are the factors of 12. So a prime number is those numbers where there are only 2 factors. So 1 is not a prime number. 1 is not a prime number. It's not a prime number because 1 has only one factor. 1 has only one factor. 1 doesn't have 2 factors. So what are prime numbers? I'll give you a list of prime numbers till 100. What are composite numbers? Composite numbers are those numbers that are formed using prime numbers. If they are formed using prime numbers, then they are composite numbers. For example, 12, 10, these are all composite numbers. So we'll write the prime numbers less than 100. When you have to memorize this. I mean, if you memorize, it's good. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 23, 29, 31, 37, 41, 43, 47, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So these are the prime numbers that are less than 100. And if you observe here, except 2, all other numbers, except 2, all other prime numbers, all other prime numbers are odd numbers. So 2 is the only even prime number. 2 is the only even prime number. So please remember this important fact. So this fact may be used and it gives a hint. For example, if they give you that x and y are two prime numbers and x plus y is equal to an odd number. So if they give you that x and y are prime numbers and x plus y is an odd number. So you should know from this thing that if two numbers are odd, so one has to be, the case would be even and odd or odd or even. And there is only one prime number which is even. So among x and y, 1 would be equal to 2. Among x or y, 1 would be equal to 2. And if they give you that x plus y is odd, xy is a prime number, and if they give you what is xy, whether it is even, odd, or something else, that is clearly an even number, because among these two, 1 would be an even number. I hope this is clear. 2 is the only even prime number, and all other prime numbers are odd numbers. So they may ask you indirectly this property. Is this clear? If you have any doubts, please ask. And if you have any doubts, please feel free to ask. Don't hesitate. See, composite numbers are any numbers which are composed of prime numbers. Numbers which are not prime numbers are composite numbers. For example, 15. This is 3 into 5. 3 into 5 is a composite number because it is composed of two numbers, 3 and 5. 20. 20 is composed of 2, 5, and 2. So I hope you understood this, Deepthi. Composite numbers. Any numbers which is not a prime is a composite number because it is composed of two or more prime numbers. And these are the prime numbers that are less than 100. And 2 is the least prime number, and also 2 is the only prime number that is even. Okay. So we'll move to the next part. So we already covered the factors. Factors are those numbers that divide any number completely. Numbers that divide any other number, any other given number completely. So for example, factors of 12, we discussed it as 2, 3, 4 and 6. So these numbers divide 12 completely, and when 12 is divided by 2, the remainder would be 0. The remainders would be is equal to 0. So these are called the factors of 12. HCF is nothing but if there are two numbers, HCF is called highest common factor. Highest common factor. So if, for example, we have 12, let's take 12 and 15. So what are the factors of 12? We have 2, 3, 4, 6 and 12. 12 is also a factor of 12. And what are the factors of 15? 3 and 5. So the highest common factor. So we have factors of 12 and we have factors of 15. These are the factors. And in these two, the highest factor, common factor that is there. Which is the common factor here? One is 3 and 5 is not a factor here. So there is only one factor common, that is 3, and that's also the highest. So the highest common factor would be, that is the HCF of 12 and 15 is 3. HCF of 12 and 15 is 3. And there is one more method where you can find out the HCF. For example, if they give you 25 and then they give you 16, if you have to calculate any two numbers, what you have to do is you have to reduce these numbers in terms of prime numbers. For example, 25 can be written as 5 into 5. This is equal to 5 square. So, okay. And 16 can be written as 2 raised to 4. So in this case, when you have to find out the HCF of these two, what you do is you take the most, the common factors here. So in this case, if there are, we have to calculate HCF. So in this case, there is no common factor. The highest common factor would be 1. And if, for example, if we have to take 3 and let's take some other numbers, 24, 24 and 52. So 24 we again 2 1s are 2, 2s are 2, 6 are 3s are. This is 2 cube into 3. And then 52 is 2, 26, 2 1s, 2 3s. This is 2 square into 13. And now if we have to calculate the HCF of these two, what we do is we take the least, the power. In this case, 2 is common. So this would, the least is 2 square. And the 3, in this case 3, you can write it as 3 is to the power of 0. There is no 3 to the power, and the least will be 3 to the power of 0. And here again 13 to the power of 0. This 3 to the power of 13. So this would be 4. The highest common factor of 24 and 52 is 4. So you should take the least power here. of the common factors. I hope this is understood. I mean, this is clear. What is HCF? What is a factor? What is HCF? And how to calculate HCF? If it's clear, please let me know. If you have any doubt, also you can feel free to. You are free. You can ask. If it's clear, I'll move to the next part. Multiples. So what is a multiple? For example, what are the multiples of 5? Multiples of 5 would be 5, 10, 15, 20, and so on. So whenever you take a number and you multiply by 1, 2, 3. See, I've not yet started Akash. I've not yet started LCM and HCF. I'm just covering, I've just covered one thing, and I'll now cover LCM also. Please be patient. So multiples of 5 are 5, 10, 15, 20. So what you're doing here is you're multiplying it. This is 5 into 1. This is 5 into 2, 5 into 3, and 5 into 4, so on. The multiples of 5 are these numbers: 5, 10, 15, 20, 25, 30, and so on. In the same way, multiples of 3 is 3, 6, 9, 12, and so on. So these are the multiples. What is LCM? LCM is called the least common multiple. The least common multiple. For example, if you have two numbers, you have to find the least. So for example, let me take 5 and 3 itself. 5. So let me list the numbers here. Multiples of 3. 3, 6, 9, 12, 15, 18, 21, and so on. And then 5, this is 5, 10, 15, 20, 25, 30, 35, 40, 35, so on. So these are the multiples of 3, these are the multiples of 5. And what is least common multiple? We have to find the common multiples, and among those common multiples, we have to select the least one. For example, in this case, 3, 5, 10, so 12, 15 is the common multiple here, the first common multiple. And then after 15, you would get, this is, if I continue like this is 24, 27, and 30. 30 would be the next common multiple. So these are the common multiples. Common multiples of 3 and 5 are 15 and 30, and so on. But the least common multiple is 15. So the LCM of the least common multiple of 3 and 5 would be 15. That is the LCM of 3 and 5. So one way to solve this is the traditional method. 3 and 5, we write it here. 3 ones are and 5, and again 5 ones are. So 3 into 5 is 15. We can calculate the LCM like this also, and also like the prime factorization method. So give me two numbers. I'll just take two numbers to calculate LCM. So LCM of, let's take LCM of 24 and 52. So what we do is, whenever we have two numbers, for example, in this case, we have to calculate the LCM of 24 and 52. What we do is we prime factorize this, write it in the prime factorization mode. What is prime factorization? We write the composite number in primes. This would be 2 1s are 2 2s are 2 6s are and 2 3s are. This can be 24 can be written as 2 cube into 3, and then 52 write it as 2 2s are 2 6s are 2 1s are 2 3s are. This is 52 can be written as 2 square into 13. This is how we write the numbers in prime factorization method as a prime factors. So 224 is equal to 2 cube into 3, and 52 is equal to 2 square into 3. And when we are finding LCM, we find the common prime numbers here and take the highest. So this is L. That means when we are kind of finding the LCM, we would consider the highest power of the common primes that are there. For example, the common prime here is 2. So this would be 2 raised to 3. And then we have 3 here. This is 1 prime 3. This is the highest would be here in this case. It can be written, we can write it as 3 raised to 0 because 1 can also be written as 3 raised to 0. So this is in among these two, 3 raised to 1 and 3 raised to 0, 1 is the highest. So we write 3 raised to 1. And then we have 13. In this case, there is no 13 in this. So I will write it as 13 raised to 0. This is 13 raised to 1. And I am comparing these two primes. 13 raised to 1, this 1 is higher. So I will write it as 13 raised to 1. So this number would be the LCM of these two numbers. I hope this is clear. I mean, this is how you find out. I mean, whenever you are calculating the LCM, you write it in the prime factorization method. And then when you take the common primes, and then among the common primes, you take the highest number of the number with the highest power. So 2 raised to 3. In this case, in this 52, there is no 3 as a prime. So we have 3 raised to 1. So this 3 raised to 1 will come here. And 13, when we compare these two, the 13 raised to 1 is the highest. So 13 raised to 1. This number, so 8 3s are 24 and then 13. This number is the LCM. But when we are calculating the HCF, we take the least here. The common primes which are there, in that we take the least. So HCF is the highest common factor, but here the powers would be the least. In this case, we are taking 2. Even among 2 raised to 3 and 2 raised to 2, 2 raised to 2 is the least. So I have written as 2 raised to 2. 3 and 3 raised to 0, 3 raised to 0 is the least, and 13 raised to 0 and 13 raised to 1, 13 raised to 0 is the least. So we have the highest common factor as 4. I hope this is clear. How to calculate LCM and HCF, and what is LCM and what is HCF, and what is a factor and what is a multiple. And the multiples would be infinite. And the factors would be finite, number of factors. Number of multiples would be infinite, number of factors would be finite. I hope this is clear, because the factors cannot be greater than the number itself. So the factors can be equal to the number, but equal to or less than the number. For example, all the factors has to be less than or equal to the number itself. And factor cannot be greater than any number. The factor of a number cannot be greater than that number itself. Is this clear till now? We have covered odd and even. I'll just go back once again. I'll give a refresher. We have seen what are numbers, types of, the classification of numbers as real number and complex numbers. Real number can further be divided as rational number and irrational numbers. Rational numbers, real numbers are those numbers that can be represented on a number line. Complex numbers cannot be represented on a number line. And then real numbers can be differentiated into, segregated into rational number and irrational number. Rational numbers are numbers consisting of integers and fractions. In fractions, we have recurring numbers. For example, 2 by 3 would be 1 by 3 is also a rational number because it is 0.3333 and so on. This is not a terminating, it's not a terminating one, terminating decimal, but it has a pattern. It has a pattern. So 3 is repeating. In these numbers, irrational numbers, there is no patterns. There is no pattern and it is not terminating. You don't have to know these minor differences. Then you have integers and fractions, and then you have whole numbers. Whole numbers contains 0, 1, 2, 3 and so on. And natural numbers is without 0 if other numbers are natural numbers 1, 2, 3, 4. And numbers, natural numbers and whole numbers are both integers. They're all integers. And after this, we have seen in integers, there is even number and odd number. Even numbers are those numbers that are divisible by 2. 0, 2, 4, 5, 0, 2, 4, 6, 8, 10. All these are even numbers. Even negative numbers are even numbers. That is, for example, -2, -4, -6, -12. All others are even numbers. What are odd numbers? Odd numbers are numbers that are not divisible by 2. For example, -5, -3, -1, -7, +1, +3, +7. All are odd numbers. What are the rules of these odd numbers and odd and even numbers? For example, in addition, whenever we add two even numbers, the result will be an even number. When we add an even number plus odd number, the result will be an odd number. And when we add odd numbers and odd numbers, we have an even number. For example, in this case, even number plus even number, 4 plus 8 is 12. And even plus odd, 4 plus 5 is 9. This is an odd. This is an even. Odd plus odd, 1 plus 1 is 2. Or 5 plus 7 is 12. Then if we subtract, again even minus even is even. It is 12 minus 8, in this case is 4. So even, this is 12 is even, 8 is even. And the answer 4 is also even. And odd minus even is odd. So 5 minus 8, 5 is even, sorry, 5 is odd, 8 is even. So this is equal to -3, this is odd. Odd minus odd is even, 5 minus 9 is -4, even number. This is even, this is odd, this is even. And multiplication, whenever you are multiplying any two numbers, you would get an odd number only if both are odd numbers, or all the numbers are odd numbers. And if any one number is even number, the final product will also be an even number. So in division, if the answer, when you divide these two numbers, that is even by odd, if you get an integer, if this is an integer, then that integer will always be an even number. And if odd by odd is an integer, and that odd number would always be an odd number. Sorry, that number integer would always be an odd number. And when you divide even by even, you can get an even number also and odd number also. And this is examples that I've taken here. 60 by 5 is 12. Since this 12 is an integer, this always has to be an even number. And 35 by 7 is an integer, and this integer will be an odd number. I hope this is clear. And then what we have seen is, we have seen prime numbers. Prime numbers are any numbers that has only two factors. What are those two factors? 1 and the number itself. These are the two numbers, 1 and the number itself. For example, the factors of 7. 7 is a prime number. The factors of 7 is 1 and 7. The factors of 17. Again, that is 1 and 17. The factors of 13 is 1 and 13. There are only two factors, 1 and 13. The factors of 19, again 1 and 19. So the numbers which has only two factors, and those two factors are nothing but 1 and the number itself, those numbers are called prime numbers. So the prime number, I'll just show you the prime numbers later. What is composite number? Composite numbers are the numbers that are made up of prime numbers. For example, 15. 15 is, or you can say, numbers which are not prime numbers are composite numbers, or integers that are not prime numbers are composite numbers. In this case, 15 is a composite number. It is composed of 3 and 5. And 20, can be written as 2 square into 5. It is composed of the prime 2 and 5. So these are the prime numbers that are less than 100, 2, 3, 5, 7, 11, 13, and so on. And except 2, all the numbers are odd numbers. Even if you go to infinity, all the numbers, prime numbers are odd numbers except 2. 2 is the least prime number, and 2 is also the only even prime number. So if you remember this property, if they give, for example, there are for 2 numbers are prime numbers, and when you add those 2 numbers, the resultant is an odd number, then one of those 2 prime numbers has to be 2. And if you multiply those numbers, since one of the numbers is 2, the result would be an even number. What are factors? Factors are those numbers. Factors of numbers are those numbers that divide the given number completely. What does it mean completely? That means when you divide that number, you would get the remainder as 0. There would not be any remainders. And the property of remainders is remainders has to be less than the number. Remainder, for example, if the number is 12, and when you are dividing any other number, when you are dividing 12 by any other number, the remainder has to be between 0 and 11. It should always be less than 12. So HCF is the highest common factor. Common factor is the numbers that are divisible by, that divide the number completely. In this case, I have taken 12 and 15 as 2 numbers. The factors of 12 is 2, 3, 4, 6, and 12. The factors of 5 is 3 and 5. The common factors between these two is 3. The highest common factor is of 12 and 15 is 3. And if you have to calculate the highest common factor through, the proper method is through prime factorization. For example, in this case, I've taken 25 and 16. What we do is we convert this 24 as a prime factorization method, and we write it as primes here. So 24 can be written as, I've used this factorization method. 2 12s are, 2 6 are, 2 3s are. So it would be 2 cubed into 3, and 52 would be 2 square into 13. And to calculate the highest common factor, we find out the common primes and then take the least power. For example, the common factors here is 2. The least power is 2 square. And here it is 3. There is 3 here. And in this number 52, there is no power of, there is no number 3 here. So it can be written as 3 to the power of 0. So the least would be 3 raised to 0. That is 1. And 13 also, 13 is not there in 24. So the least would be 13 raised to 0. So the HCF would be 2 raised to 2, that is 4. This is the method of calculating the HCF. And then multiples. Multiples are those numbers. When you multiply the number, any number with integers like 1, 2, 3, 4, you would get the multiples. Multiples can also be negative and it can also be positive. So if I multiply 5 by 1, I would get a positive multiple. If I multiply 5 into minus 1, I would get a negative multiple. Even minus 5 is a multiple of 5. And to calculate the least common multiple, multiples can be infinite. The number of multiples can be infinite. And to calculate the least common multiple, what we do is one method is to write down all the multiples and then find the common multiples here. So common multiples here is 15 and 30 and so on. And the least common multiple among these multiples are 15. Or you can use prime factorization method. In prime factorization method, you again write those numbers in prime factorization method. 2 cube into 3. This is 2 into 2, 2 12s are, 2 6s are, 2 3s are, 2 cube into 3, 2 into 2 into 3. And then 52 can be written as 2 square into 13. And then for calculating LCM, you find the common prime numbers which are there, and then you take the highest power. In this case 2, the highest power is 2 cube. When you compare 3 and 2, 3 is the highest. So this is 2 cube. And here there is 3 raised to 1, and here there is 3 raised to 0. There is no 3. The highest is 3 raised to 1. And here there is 13. And here there is no 13. So I can write it as 13 raised to 0. The highest will be 13 raised to 1. So this is the LCM of that number. So the number of multiples will always be infinite. but the number of factors would be always be finite because the factors cannot exceed the given number. It should be less than or equal to that number. I hope this is clear. If you have any doubts till now, please ask. Okay, then I'll move to the properties of integers. So just like even numbers, whenever we are adding two integers, integer plus integer will give you an integer. Integer minus integers will give you an integer. Integer into integer will give you an integer. But integer divided by an integer, you cannot say this, we cannot say this can be integer or a decimal. Okay. Integer plus integer is always an integer. Integer minus integer is always an integer. Integer into integer is integer. Integer divided by an integer is, I mean, you cannot say whether it is an integer or not. And there is one thing here. If they say x plus y is equal to integer, that doesn't mean x is an integer and y is an integer. You have to remember this important thing here. Because, for example, 2 plus 2.5 plus 3.5 is equal to 6. So when two fractions or two decimals, when you add two decimals, you can get an integer. When you add two decimals, decimal plus decimal can give you an integer. So just by seeing the result here as an integer, you cannot conclude on whether the x or y is an integer. So please be aware of this and don't fall into the trap. And you can say that integer, if two numbers are integers, the addition of those two numbers, subtraction and multiplication of those two numbers, if they are integers, then the result will also be an integer. But you cannot say that if the result is an integer, then the components will also be an integer. You cannot say that. I hope this is understood till now. Is it clear? Can I move to the next part? Okay, we'll cover this last aspect here, the rules of divisibility. So we'll take one by one, the most common ones. If a number is divisible by 2, then the units digit of that number should have 0, 2, 4, 6 or 8. So for example, if we are taking 85, the number is 85. This is not divisible by 2 because the units place number 5 is not an even number. I hope this is clear. It has to be, this number unit place has to be 0, 2, 4, 6, 8. And then 3. If any number would be divisible by 3, if the sum of the integers digit is divisible by 3. For example, let's take 27. To check whether 27 is divisible by 3, we have to add the digits here. 2 plus 7 is 9. 9 is divisible by 3. Let's take 352. Now whether to check whether this 352 is divisible by 3, what we have to do is we have to add these 3 digits. 3 plus 5 is 8. 8 plus 2 is 10. And 10 is not divisible by 3. So this is not divisible by 3. This is divisible by 3. And similarly, you can check any numbers. For example, UPSC has given sometimes a very large number, and the only thing that you have to do was to calculate, to add those digits of those numbers and find out whether that number is divisible by 3 or not. Is this clear till now? Okay, we'll take the next number 5. Sorry, 4. If any number has to be divisible by 4, then that number has to be divisible by 2 twice, or the last two digits of that number has to be divisible by 4. Has to be divisible by 4. For example, let's take 216. So what they're saying is, if that number has to be divisible by 4, then that number has to be divisible by 2 twice. For example, if I divide this by 2, this has to be divisible by 2 twice. So once if we are dividing it, this would be 108. Then I can again divide it by 2. This is 54. So this number 216 is divisible by 2 twice. Hence this 216 is divisible by 4. See, 4 means 2 into 2. So if the numerator has 2 into 2, then it is clearly divisible by 4. Or what they are saying is, in this case, 216, if this 16, the last two digits, if these two digits are divisible by 4, the 16 is divisible by 4. Hence, this number is also divisible by 4. For example, you can take any number, 873587216. This number, is this number divisible by 4? Yes, the last two digits is divisible by 4. And this is the power of the rule. It can be any large number, but if the last two digits are divisible by 4, then this number would be divisible by 4. I hope this is clear. Okay, then we'll end the session here. We'll continue the basics tomorrow also. There are still a lot of things to cover. It's already 9:15. Sorry for extending by 15 minutes there, and sorry for the technological